Okay, so in this lesson, we're going to continue talking about solving quadratic equations by factoring, part two. All right, again, remember, not all quadratic equations can be solved by factoring. In that case, we would need to use quadratic formula. But for right now, every one of these problems we'll be able to solve by factoring. Also remember in the previous lesson, we solved these quadratic equations by factoring using the zero factor property. Okay, so remember the zero factor property said that, let me find it, in the previous lesson, the zero factor property said that if you have two or more factors whose product is zero, then at least one of those factors had to be zero. One of those factors had to be zero. And so you remember we said each of those factors equal to zero. But in order to use the zero factor property, zero has to be on the other side. Okay? So you have to factor and set each factor equal to zero. So the next thing I want to show you then is this: the steps to solving a quadratic equation. The steps to solve a quadratic equation. Step one is that you're going to write the equation in standard form. So remember, standard form is where you had ax squared plus bx plus c equals 0. So it's kind of like this one here. X squared minus 9x minus 22 equals 0. 2x squared minus 7x minus 4 equals 0. Okay? So this is not standard form. This is not standard form. So you have to rewrite it so that way it looks, or it becomes, standard form. All right. So once you write in standard form and you have 0 on the other side, you got to have 0 on the other side, then you factor the quadratic expression. So then you're going to use all the factoring techniques that you learned in the previous chapter. Then you're going to use the zero factor property. So you're going to set each factor equal to 0. Then you're going to solve each of those equations, and then you check your answer if you have time. On the test, you're not going to have time, but technically you would want to check your answers, okay, in the original equation. All right, so let's look at some examples. Let's solve each of these equations. All right, number one. Suppose we had x squared minus 13x plus 36 equals 0. So x squared minus 13x plus 36 equals 0. Now, you see how this is quadratic. So this is quadratic equation. You have an x squared. The exponent 2 is the largest exponent, so it's quadratic. So you'll notice that in all of these problems that we're going to do, you're going to get a maximum of 2 solutions. Now, you'll see in some cases there's only one distinct solution, but you're going to get a maximum of 2. You won't have 3 solutions. You won't have 4 solutions. If it's quadratic, if this is a quadratic equation, you'll have at most 2 solutions. Okay? All right. So again, step 1 says to make sure it's in standard form and equal to 0, and it is. This is standard form, and it's equal to 0, and it helps if it's in descending order. Okay? So that was step 1. So step 1's already done. Step 2 says factor the quadratic expression. So on this side, we're going to factor. So that's where all of your techniques are going to be used. So the GCF is 1. So I'm just going to go ahead directly to the 2 factors whose product is x squared minus 13x plus 36. So again, we're going to say x times x. I'm going to do this by trial and error. The last sign's positive, so that means both of these signs are the same, so I know they both have to be negative. And I need 2 factors, that's 36, because I'm going to go into these 2 spots. But I need the outer and the inner to be a negative 13. So the only possibility for that is 9 and 4. But check yourself before you go on, just like you did in the last chapter. The outer, we're just checking, x minus 9, x minus 4. The outer is negative 4x, the inner is negative 9x, and when I add them up, I do get a negative 13x. Okay, so that was step 2. So step 2 said to factor the quadratic expression completely. All right, so now remember, in the previous lesson, when we did problems like this, so if I had If I had two factors whose product was 0, then remember I use a zero factor property. So the zero factor property says I set each factor equal to 0. One of those factors has to be 0. So remember I went from a quadratic equation to two linear equations. And so you ended up with two solutions. In this case, it will be 3 and -1 are your solutions. So in this case, again, I'm going to use the zero factor property. So the zero factor property. So zero factor property is what I'm using now. So about a zero factor property, I'm going to set each of these factors equal to 0. So I get x minus 9 equals 0, and I get x minus 4 equals 0. And then notice I went from a quadratic equation to two linear equations, and that just solved for x. So x is 9 and x is 4. So those are your two solutions. All right, and then you can check this. Okay, so you check x equal 9. Now again, the directions said, the step said check each solution in the original equation, because you could have messed this up. You could have factored this wrong. So if you put this back in here, you're going to think it works, but you got to go back to the original. Okay, always go back to the original, because you could have made an error somewhere in here, and then when you factored it. So I have x squared minus 13x plus 36 equals 0. So wherever I see an x, I'm going to plug in 9. So I get 9 squared minus 13 times 9 plus 36, and I want to see that's equal to 0. Well, use your calculator. So you're saying 9 squared, I got to remember how to, so 9 squared is 81. Now that's not your calculator, it's not the calculator that we use in class, but that's the only one I have available. Minus 13 times, oops, okay, so I'm going to have to do this the long way. So 9 squared is 81, 13 times 9 is 117, and then plus 36. Using the order of operations, 81 minus 117 is a negative 36. So again, I want to see if that's equal to 0. A negative 36 plus a 36 is equal to 0. So x equal 9 works. Now if you do x equal 4, the same thing should happen. All right, so if you want to go ahead and check it, you can. That's 4 squared minus 13 times 4 plus 36. And I want to see if that's going to equal 0. Well, 4 squared is 16. 13 times 4 is 52. 52 plus 36. So order of operations, 16 minus 52. I get negative 36. Negative 36 plus 36 is 0. Okay? All right, so those solutions do work. So those are your two solutions. So that's checking in the original. All right, let's look at number 2. So number 2, suppose we had x squared minus 4x equal 32. So x squared minus 4x equal 32. Again, step 1 says you must write the equation in standard form so that 0 is on the other side. So this is not in standard form. Standard form means you got to bring all the variables, all the terms to one side, and let's put in descending order. So if I bring the 32 over, I'm going to have x squared minus 4x minus 32 equals 0 because it's positive on this side. So if I subtract 32, remember what we're doing if you don't see it. So I subtract 32 from both sides. This is what this is. So x squared minus 4x minus 32. That's this. And then equal, and then over here, 32 minus 32 is 0, so that's where this comes from. Okay, so now it's in standard form. So now step 2 says I factor the quadratic expression. So the one on the left, this quadratic expression, if you cover it up, this is quadratic expression. The GCF is 1, so I'm going to go directly to the two binomials. So you factor this. This is not that bad because the x squared has a coefficient of 1, so I know this has to be x and x. The last sign is negative. It means these signs in here are different. And when I do, I'm going to go ahead and factor it out here. And when I And when I check the outer inner better be a negative 4x. So if I try, let's say 8 and 4, 8 and 4 is 32, so that is, the outer is 4x, the inner is 8x. The larger of these takes that middle sign, so that has to be negative. When I add them up, I do get a negative 4x. So those are correct. Those are correct terms. So that means this is negative and this is positive. So I get x minus 8, x plus 4 equals 0. You got to make sure you say equals 0. Don't just say x minus 8 times x plus 4. All these have to be equivalent. So you have to say equals 0, equals 0. Now, remember, if you have two or more factors whose product is 0, I said each of those factors equal to 0. And I'm using the 0 factor property now. So the 0 factor property. So the 0 factor property says that if x minus 8 times x plus 4, if that product is equal to 0, then one of these has to be 0. So x minus 8 has to equal 0, or x plus 4 has to equal 0. So I went from a quadratic equation to two linear equations. So here I get x to be 8, and here I get x to be a negative 4. Okay? So those are your two solutions. And again, I'm just going to check one. I really don't have much time to check all of them. But let's just check x equal, let's do that negative 4. Let's check x equal negative 4. So I get x squared minus 4x. I want to see if that's going to equal 32 when I plug in negative 4 into x. So I get negative 4 squared in parentheses. Make sure you put negative 4 in parentheses because x is negative. Minus 4 times negative 4. And I want to see if that's going to equal a 32. All right, well, negative 4 squared is a positive 16. So make sure if you're using a calculator, you put negative 4 in parentheses and then squared, because negative 4 in parentheses squared means negative 4 times negative 4, which is a positive 16. And negative 4 times a negative 4 is also a positive 16, and so 16 plus 16 is equal to 32. Okay, and you do the same thing for 8, and you'll see it will check out. All right, that's number 2. Okay, number 3. Let's suppose we had x squared equal 16. X squared equal 16. Okay, so again, you got to make sure it's in standard form. That's step 1. So I'm going to bring the 16 over. So I get x squared minus 16 equals 0. So you remember you got to have 0 on the other side. Then notice, though, that you want to factor the left side now. You want to factor this quadratic expression. Well, remember, this is the difference of two squares. So when I factor this, I get x minus 4 times x plus 4 equals 0. And then by the 0 factor property, I said each of these factors equal to 0. X minus 4 is equal to 0, or x plus 4 is equal to 0. So I went from a quadratic equation to two linear equations. And so my solutions are 4. And over here I get a negative 4. All right, and let's just check one of them. Let's check x equal negative 4 into the original. So here's my original. Let's go back to the original. Don't go back to any of the others. Go back to the original, because you could have made a mistake somewhere along the way. So x squared equal 16. So I'm saying x is negative 4. So the question is negative 4 in parentheses squared the same thing as 16? And the answer is yes. All right. So there's your two solutions here. Now sometimes you'll see how these are opposites of each other. So sometimes you'll see it written like this, plus or minus 4. So you'll see it written like this. These are opposites. Okay. So plus and minus 4, positive 4 and a negative 4. Okay, so let's look at number 4. Suppose we had, let's see. All right, suppose we had this. Suppose we had y minus 2 times y plus 3 equal 6. Y minus 2 times y plus 3 equal 6. Okay, so this is, if you're not careful, here's what's going to happen. You're going to remember the zero factor property. So the zero factor property kind of looks like the zero factor property. So you're going to say, all right, I have two factors whose product is 6. Okay, so remember, I have two factors product of 6. Now this is wrong. I'm just telling you what you're going to do if you're not careful. This is wrong. So you're going to think, okay, I have two factors whose product is 6. I'm going to say each one of those equals 0. And that's what some of you will do at first. You're going to do that. All right, so you went from this quadratic equation to these two linear equations, and you solve for x. So here, I add 2 to both sides. Oh, that should be a 6 here. I add 2 to both sides, and I get y equal 8. Here, I subtract 3 from both sides, and I get y equal 3. All right, but let's check both of those. Let's check them. All right, if I check 8 first, let's check 8. That's y equal 8. And I'll go back to the original. Y minus 2 times y plus 3 equals 6. So if I let x be 8, I get 8 minus 2 times 8 plus 3, and I want to see if that's going to equal 6. I'm sorry, right here. So I get y minus 2 times y plus 3 equals 6. So wherever I see a y, I plug in 8. Well, 8 minus 2 is 6. 8 plus 3 is 11, but that is not equal to 6. 6 times 11 is 66. So 8 is not a solution. Okay, so that's not a solution. So if I check y equal 3, let's see what happens. So back to the original. Y minus 2 times y plus 3, and I want to see if that's going to equal 6. Well, if y is 3, I get 3 minus 2 times 3 plus 3. And again, I want to see if that's equal to 6. 3 minus 2 is 1. 3 plus 3 is 6. And that does equal 6. So the solution is 3 that you would say. But remember, the issue is this. This is a quadratic equation. You need to have at most how many solutions? 2. You're going to have 2 solutions here. So something is wrong. There's supposed to be 2 solutions. So if you do it this way, this is wrong way now. That is incorrect. You're only going to get one of your solutions. You see, you only got one solution. So that's why it's important that on this side you have the number 0. So the zero factor property says that if two factors, in this case 2 factors, if 2 factors whose product is 0, then I know for certain that either this one is 0 or this one is 0. Here, I have 2 factors whose product is 0. I don't know what either of those factors could be. For certain. This could be a 2, this could be a 3. This could be a 6, this could be a 1. This could be a 1/2, this could be a 12. I don't know for certain what those are. But if it's 0, then I know for certain that either this one's 0 or that one's 0. That's why you have to have a 0 here. So all this is incorrect. All this is incorrect just to show you that if you do make that mistake, you only get one solution, but you're going to lose most of your points. You will lose most of your points because you did not realize that you have to have a 0 here. Okay, so let's do that same problem over, and let's do it correctly. So here's what you would do in number 4. Here's what you would do. So you would have y minus 2 times y plus 3 equal 6. Okay, so step 1, remember step 1 says, write the equation in standard form so that 0 is on the other side. Okay, so the first thing you have to do is to notice 0 is not on the other side. So the first thing you have to do, though, is get rid of these parentheses here. So I'm going to use the FOIL method. So let's use the FOIL method on this. So first times first, y times y is y squared. The outer is a 3y. The inner is a negative 2y. And the last is a negative 6. And that's equal to 6. So all I did on this side was use the FOIL method. First, outer, inner, last. Now I'm combining like terms. So I get y squared plus y minus 6 equal 6. Okay? Now I'm going to put this in standard form. So I'm going to subtract 6 from both sides. So I get y squared plus y minus 12 equal 0. So now this is standard form. So those are the work you have to do to get to standard form. And now you factor and then you would use the zero factor property. So now 0 is by itself. So y, the last sign's negative. These signs in here are different. I need to get a negative 12 in the end, so this would have to be a positive 4, and this would have to be a negative 3. And you can check yourself. Negative 4 times negative 3 is a negative 12. The outer is a negative 3y. The inner is a 4y. When I add them up, I get a positive y. And so by the zero factor property, I set each of those factors equal to 0, because one of them, I know for certain that one of these has to be 0. So y plus 4 equals 0, or y minus 3 is equal to 0. And notice I'm going from a quadratic equation to 2 linear. So my solutions are negative 4 and 3. All right, so those are your two solutions. Now you can check, and we always go back to the original. Let's just check y equal negative 4. Let's just do that one. Let's check y equal negative 4. So my original is this. Y minus 2 times y plus 3 equal 6. So wherever I see a y, I'm going to plug in negative 4. So negative 4 minus 2 times negative 4 plus 3. And I want to see if that's going to equal 6. Well, negative 4 and a negative 2 is a negative 6 times negative 4 plus 3 is a negative 1, and a negative 6 times a negative 1 is equal to a positive 6. So negative 4 works. And you do the same thing with 3, and you'll see that 3 works as well. Okay? All right, so that was that one. Let's do one more with this. All right, one more with this. Let's suppose we want to, all right, let's look all right, let's look at this one. So this is going to be negative 3x squared plus 75 equals 0. Negative 3x squared plus 75 equals 0. Okay, so again, remember the step 1 is to write the equation in standard form so that one side of the equation is 0. All right, so by looking at this, it is in standard form. All right, then you want to factor a quadratic equation. You want to factor a quadratic expression. So here, though, notice here, I can factor out, and let's factor out a negative. I can factor out a negative 3. So I get negative 3 times x squared minus 25. Negative 3 times x squared is a negative 3x squared. Negative 3 times a negative 25 is a positive 75. And remember, this right here is the difference of two squares. So I get negative 3 times x plus 5 times x minus 5, and all that's equal to 0. Okay? All right, now I want you to notice something. So technically you have three factors here. You have negative 3 as a factor, you have x plus 5 as a factor, and you have x minus 5 as a factor. And remember, the zero factor property says you set each factor equal to 0. But when we say that we set each factor equal to 0, we're considering that those factors have to have variables in it. So that's why you'll see in this step, it says set each factor containing a variable equal to 0. So notice, see that first factor? That's a negative 3. So negative 3 does not contain a variable. So I'm not gonna set equal to 0, because first of all, negative 3 equals 0 makes no sense. So you're going to set only the ones that contain a variable. So you're going to say x plus 5 equals 0, or x minus 5 has to equal 0. And so your solutions are negative 5 and 5. Okay? So if you check it, let's just check one of them. Let's just check x equal negative 5. All right, you go back to the original. So I have negative 3 x squared plus 75, and I want to see if that's going to equal 0. Where's it equal 0? So let's check negative 5. So I got negative 3 times negative 5 squared plus 75, and again, is that equal to 0? Well, order of operations, negative 5 squared is 25. Negative 3 times 25 plus 75, is that equal to 0? Negative 3, right here. Negative 3 times 25 is a negative 75, and negative 75 plus its opposite is equal to 0. Okay? All right, so we're going to stop at this one, and then we'll do some more in the next lesson.